Hi folks, this is Calc 2 Take Home Assignment 6. I know it says 5, but that's a typo. It really is Take Home Assignment 6. We're given an infinite series and we're asked to determine a formula for the kth partial sum and then to use that to show the series is convergent. So for part A, we're going to take this 3 over 9n squared plus 3n minus 2 and we'll follow the hint. The hint says to use partial fractions. So to use partial fractions, we need to factor the denominator. So we can go through our algebra 2 here. It's going to be 3n minus 1, 3n plus 2. And so that gives us the form of the decomposition is a over 3n minus 1 plus b over 3n plus 2. Since we have distinct linear factors here, I can use the Heaviside cover-up method to determine the a and the b. So I look here. What value of n would get us in trouble here? N equals 1/3. So I go back to my original fraction, cover up the 3n minus 1. If I plug n equals 1/3 into this, I get 3 over 3, which is 1. So I get a equals 1. The value of n here, which would screw this up, would be negative 2/3. So I go back, cover this up, substitute negative 2/3 into what remains. And that's going to give me 3 over negative 3, which gives me b is negative 1. So what that means is I can take this and break it into 1 over 3n minus 1 minus 1 over 3n plus 2. So in other words, this guy is the same as summation n equals 1 to infinity, 1 over 3n minus 1 minus 1 over 3n plus 2. And so this is the description we'll use then to write our partial sums. So S1 is the first partial sum. I plug in n equals 1. I get 1/2 minus 1/5. For S2, I take the sum of the first two terms, so S1, I have 1/2 minus 1/5, plus, plug in n equals 2, I get 1/5 minus 1/8, and that simplifies. The fifths cancel out to 1/2 minus 1/8. To get S3, I'm going to take S2 and add the third term, so that's 1/2 minus 1/8. Plus what I get when I substitute 3 in, that's 1/8 minus 1/11. And we see that the 1 at the 8th canceled out, and I get 1/2 minus 1/11. And this is going to go on in this fashion. And so SK is going to be 1/2 minus 1 over 3k plus 2. All right, so that's part A. So for part B now, we're asked to use this then to prove that the series converges. So SK is 1/2 minus 1 over 3k plus 2. And so the summation n equals 1 to infinity of 3 over 9n squared plus 3n minus 2 is by definition the limit as k goes to infinity of the kth partial sum. That's the limit as k goes to infinity, 1/2 minus 1 over 3k plus 2. As k traipses off to infinity, I get 1 over a very large positive number. This in fact is going to 0, and I'm just left with 1/2. So by definition, as the series converges, moreover it converges to the value 1/2. And that'll do it for take home 6.